This is the key to page 1 of review worksheet for chapter 11. So on number 1, I'm supposed to find the third term in the expansion of 2x plus y to the 7th power. So I know there'll be 8 terms in all in that expansion, and I will be taking the coefficient that I get from Pascal's triangle and multiplying it by 2x, the base of 2x to some power times the base of y to some power. And I know that when I do this 2x, if I start with the first term, the exponent on that base is going to run from 7 all the way down to 0 for the 8 terms. And on y, the exponents will run from 0 in the first term all the way up to 7. So if I find the coefficient of the third term, first of all, in Pascal's triangle, first of all, if I started with row 6, I generated row 7, and so the third term, 1, 2, 3, would have a coefficient of 21. So I'm going to take 21 times, and then I'm going to take 2x. Now the third term, if I start with 7, 7, 6, 5, this will have an exponent of 5 on this base, and if that base has an exponent of 5, the other base will have the exponent of 7 minus 5, or the other 2. Because remember, these two exponents have to add to the 7. So this is going to be 21 times 32x to the 5th y squared, and that is 672 x to the 5th y squared, which is choice B. Okay, for number 2, it's a binomial expansion, x minus y to the 5th. And I'm going to check the coefficients first of all, because these are all multiple choice. I do know that my first base will be a positive x, and those exponents will go from 5 down to 0. And my second base will be a negative y, and those exponents on that base will go from 0 up to 5, and there will be 6 terms. But this one, because this is negative, I know that I'm going to alternate in sign from positive to negative to positive to negative. So let's go through the looking at the coefficients for these. So for row 5, my coefficients are going to go 1, 5, 10, etc. And I notice that these are different by the second term, so I'll just generate the first 3 terms. So on this we get x to the 5th, negative y to the 0. And on our second term we'll have the coefficient of 5 times x to the 4th, negative y to the 1st. And our third term will have a coefficient of 10, x to the 3rd, y to the 2nd. Okay, so my first term, this negative y to the 0 is 1, 1. This is just x to the 5th. This is going to be a negative because I have a negative y to the 1st, 5x to the 4th, y. So it's looking like it's going to be a, but just to confirm it, plus 10x to the 3rd y squared. That would have to be choice A. So you don't have to generate this one, all of the terms, to be able to tell which sequence it is. Okay, number 3, we're supposed to find the 34th term in the arithmetic sequence, 9, 6, 3. So I can see that the first term is 9, and the common difference is 9 minus 6, or negative, well, I'm going down by 6, 6 minus 9, so the common difference is negative 3. So to find the 34th term, if I start with the first term, I have to add the common difference 33 times. So that would be 9 plus 33 times negative 3, which is 9 minus 99, or negative 90, which is choice B. Okay, now for number 4, the 31st term, and I'm given the 5th term and the 9th term, so let me line those up. The 9th term, I'll put that one first, is 12.0. The 5th term is 3 2/10. So I'm going to find the common difference, understanding that it's like a slope or rate of change. So if I look at the change in the value over the change in position between those two terms, I have a change in value of 12.0 minus 3 2/10 over 9 minus 5. So this is 8 8/10 divided by 4, or 2 2/10. So now I'm gonna just start with the 9th term, since that's closest to the 31st term. And so if I frame how I'm going to get that, I'm going to say, well, my 31st term, if I start with my 9th term, I would have to add 31 minus 9, which is 22 common differences. So starting with my 9th term, which is 12, I should have to add 22 times 2 2/10. So when I do this, I get 60 4/10. So that would be choice D. Okay, back to number 5. We have the second term in an arithmetic sequence and the 7th, and we have to find the nth term of the sequence. So the second term is 12 and the 7th term is 67. Again, change in value over change in position would be 67 minus 12 over 7 minus 2, so 55 over 5, or 11. So I have a slope or a common difference of 11. So I'm pretty much knowing that it's going to be A or B. But if I look at this, if I just want to go back to the first term, if I know the common difference that was added was 11, to get back to the first term, I know that that must have been 1. Just take 12 minus 11. So the first term in this was 1. And to write the nth term formula, I'm just going to say that, I'll do it up here, the nth term should be the first term plus n minus 1 common differences. So in this case, 1 plus n minus 1 times 11. We'll continue this here. So 1 plus 11 n minus 11, or 11n minus 10. So that would be choice B. And you can check that out by taking the 7th term, which is 67, and if I take, that's the 7th term, 11 times 7 is 77, minus 10, and confirm that you get that term as a check. Okay, number 6, the 9th term of this arithmetic sequence. So the first term is TA minus B, and then the second term is A, and the third term is B. And this is arithmetic, so there's a difference. So I'm going to take a term and subtract the term in front of it. I'll just say the third term minus the second term is B minus A, and I'm thinking that that's my common difference. And I can confirm that if I take the first term of 2A minus B, and I add the common difference of B minus A to that, I get A, which, because the B's eliminate, and that works. And then if I add B minus A to that, I get B for the third term. So the common difference is B minus A, and now I've got to find the 9th term. So the 9th term would be equal to the first term plus 8 common differences. So the first term is 2A minus B plus 8 times the common difference, which we said is B minus A. So when I simplify this, I get 2A minus 8A, I get negative 6A plus 7B. So that would be choice B. Okay, so the 9th term, we're on number 7, the 9th term of the geometric sequence 5 root 2, 10. So in this one, if I divide 5 root 2 by 5, I get square root of 2. If I divide 10 by 5 root of 2, I get the same thing. So let's go 5 root 2 divided by 5. I get that the common ratio is square root of 2. So I can see if I multiply each term by here by square root of 2, I get the next term. So to find the 9th term, If I know the first term, I can multiply it by the common ratio, 9 minus 1, or 8 times. So in this case, I can take the first term, which is 5, times the common ratio, which is square root of 2 to the 8th power. So I can look at that as 5 times 2 to the 1/2 to the 8th, or 5 times 2 to the 4th power, which is 5 times 16, which is 80. So that would be choice E. Okay, number 8, 20th term of this progression. And it's a geometric sequence. So if I take a term like the second term, that's all I've got, and divide it by the first term, 1 over a, this is a squared times a, or a to the third for the common ratio. So, if I multiply this by a to the third, I get a squared. So the 20th term, if I know the first term, which I do, should be the first term times 20 minus 1. So the common ratio raised to the 20 minus 1, or 19th power. So in this case, the first term is 1 over a, which I could call a to the negative 1 if I wanted, times the common ratio, which is a to the third to the 19th power. So this is 1 over a times a to the 3 times 19, or 57. And so that is going to be a to the 56th power, which is choice C. Let's see, number 9, determine the common ratio for this geometric sequence. Well, if I just take this second term and divide it by the first term, I have 4/3. And if I can, to check it out, if I multiply 4 by 4/3, I do get the third term, which is 16/3. So that checks. So that would be choice E, 4/3. So that's it for page 1.